Make sure you put your name, date, period, and the topic. The topic is about intersecting secants. And by the time we're done, you're going to be professionals at this. You're going to be better than I am. The objective, by the time we're done, we're going to be able to solve problems involving segment lengths from two intersecting secants. Now I know that sounds kind of wordy and confusing, but don't you worry about it, because I'm going to draw a picture. I'm going to make sure you know everything you're supposed to know, and I'm going to try and do it as quickly as possible without confusing anyone. So, the question of the day to start with: what is a secant? Question mark. That would be really nice to know, wouldn't it? And the answer is this. A secant is a line that intersects a circle twice. That means 2 times. Now write that down, and if you're wondering what that means, I'm going to draw a picture of it. We'll take one step at a time. So here is a diagram. So the diagram would look like this. Suppose you have a circle. However you draw your circle. I hope it looks better than mine. Now, if you draw a secant, a secant is nothing more than a line like that. But notice how it touches the circle twice? That's a secant. That's a secant. See how it touches the circle twice, but it's a line. Now, the other day, we learned about something called a chord. And I'm just going to take the time to draw a chord. Notice that a chord also intersects the circle twice, but the chord does not extend beyond the circle. As a matter of fact, a chord has both of its endpoints on the circle, and it begins on the circle and stops on the circle. It never exceeds the boundaries of the circle. But a secant does. Yes, it has 2 points on the circle, but it goes on and on beyond the boundary of the circle because it's a line. So a secant cannot be a chord because a secant extends past the circle where a chord does not. Does that make sense how I compared those two? Yeah, a chord is not a secant. That's why. Any questions with that? Okay. So today's focus is about the secant. And I'm going to do 2 examples. I'm going to give you 4 problems to work out. You'll be done before you leave class. Okay. So now, this is an example of what you'll see. And while doing the example, I'm going to show you the concept that you're going to use for all these problems. Okay, so the example would look something like this. The example would be, okay, so find x. Find x. All right, so in the course of this problem, I'm going to show you the concept that you'll use. So here it is. They're going to give you a circle, a nice, wonderful circle like mine, and they're going to give you a secant, and then maybe another secant. Notice these secants hit the circle twice, but also notice that they intersect each other on the outside. Yay! Copy that. You're copying, you're copying, you're copying, you're copying. Don't worry, I'll go back to that. Maybe they'll tell you that this is 8 from here to here, and maybe this is x, and maybe the length of this piece is 6, and maybe the length of this piece right here is 10. Okay, I'm just giving you some values. Okay. Did y'all copy that? Okay, so they're going to give you a setup like this. Now, you take note. Embedded in this lesson is the concept that you'll use. And if you don't know the concept, you can't do any of the problems. So I'm going to give you the concept. Then I'll explain the concept so you don't freak out. Ready? All right. Notice on this secant, let's call this secant A and let's call this secant B. Can we do that? So if I'm talking about secant A and secant B, that way I don't have to say this one, that one, the other one. Okay. So notice on secant A, the first secant on top right there. Notice that the secant is this whole entire line here. Well, I made them line segments. But notice that it's been divided into two segments. You got the outside segment. And can anyone tell me the length of the outside segment? It's 8. And it's also got, they also give you the length of the inside segment, which is what? From here to here, what is the length of that segment? It's x. It might not be a number, but it's the length. Look at secant B. What is the length of the outside segment? 6. What's the length of the segment that's on the inside? 10. So you need to know the difference between the outside segment versus the inside segment, because this is what the concept says. Now, it's going to be kind of wordy, so I'm going to be very careful with you. Okay, the concept states that if you now I'm going to say it in words, then I'm going to try and put it in writing. Okay, so please bear with me, okay? In student-friendly language. It's not going to sound like we're some sort of NASA institute. But if you look at the outside length, the outside segment, And if you multiply that outside length times the inside and the outside added together, like for example, if you take the outside segment, whatever the length of the outside is, the outside times whatever the outside length is, times the sum of the outside with the inside. In other words, if you take the outside times, then that's the parenthesis, the outside plus the length of the segment that's on the inside. This is what I'm saying. The outside times the outside and the inside added together, if you multiply those together, any questions with that? If you take the outside number, which is 8, and multiply it by 8 plus x, it's going to be equal for both secants. That little thing is equal for both secants. Just write that down. Then I'll show you by 2 examples. After the first one, you're going to be like, dang, I got this. I ain't got no problem with that. And it looks like this. Let me show you what it looks like. Did y'all copy that? Outside, open parentheses, outside plus inside is equal. They're equal for both sequences, for both secants. It looks like this. I'm going to show you right now. It means, this concept means the way you create your equation is by taking, like say the outside for secant A. What's the outside? Multiplied by the sum of the outside with the inside. Now 8 plus x is definitely, here's the first mistake kids make. 8, the sum would be adding. 8, the outside, plus the inside. What's the inside value? X. Now 8 plus x is not 8x because they're not like terms. You cannot add them. So it stays like that. But I got news for you. If you multiply the outside value and multiply it by the sum of the outside with the inside, it's going to be equal to if you did the same thing with the other secant. Like on the other secant line, what is the outside value? Which one of those is the outside length? On secant B, which is the outside length? 6. So if you take the outside length and multiply it by the sum of the outside and the inside, sum means add. So if you take the outside length, which is 6, plus the inside length. Now what's the inside length? 10. When you do that little pattern, it's equal for both of the secants. They're always equal that way. So you create the equation by multiplying the outside, and you multiply that with the sum of the outside and the inside. That's the sum of the outside and the inside. It means 8 plus x. And if you solve that, you are set. Like, for example, the way I would solve it, since I cannot add those, I would distribute the 8. And I'd say 8 times 8, which is 64. 8 times x is just plain old 8x. Now, if you remember your order of operations, or just use the calculator, if you use the calculator, I love the calculator for this, check this out. You can go like this, you can go 6, hit the times. Now if you have 6 plus 10, you got to use open parentheses. See how it gives you a little open parentheses up there? 6 plus 10. If you close the parentheses, it gives you 16. And when you press equals, it multiplies, so that's going to be 96. And if you want to use the old-fashioned way, and you have 6, open parentheses, 6 plus 10, remember, 6 plus 10 is really what? And then you still got to multiply it by 6. That's still going to give you 96. When I solve this, I'm going to subtract 64 from both sides. Cancels. So I get 8x's are equal to 6 minus 4 is 2, 9 minus 6 is 3. I should use a calculator. And then finally, divide both sides by 8. Divide by 8. So what does x end up equaling? 4. Done. Hello. Copy that because I'm going to give you another one for us to do together. Then we're just going to look at the assignment. Now you could get a decimal. Okay, example 2. Circle, secant, secant, 6, let's call it x, and I don't know. Ten. Hopefully this will work. 12. Sometimes I make up problems and they don't work out. Okay, so nevertheless, our job is to find x. I'm praying this works. I just made the numbers up. So, do you remember the concept? If you take the outside times the sum of the outside and the inside, they equal for both secants. Let's start with the one with the x in it. What do we write first?
6.
Yeah, the outside, which is 6. Now, how do we take the sum of the outside with the inside lengths? Well, that just means add. What's the outside? 6. And what's the inside? Just add them. 6 plus x. That has to equal the same thing for the next set of the next secant. What number do I write down first? 10. But what do I multiply the 10 by? And we all know it's going to be the sum of the outside with the inside. And what does sum mean in mathematics? Add them. So the outside plus the inside. And that's it. That's the equation. Now, if this works or not, that'll be a miracle. I don't. But that's the concept. The outside times the sum equals the outside times the sum. Now, in this case, you can't add 6 and x because they're not like terms, but what's 6 times 6? Thank you. And then 6 times x? Yay. And then you could distribute the 10, but I probably wouldn't. I would follow the order of operations and just simplify that. How about saying like 10? What's 10 plus 12? Amen. And so I would just drop this down one more time and multiply that. That's 220. And to finish solving for x, what am I going to have to subtract from both sides? Yes, I am. And I'm definitely going to use a calculator because by period 7, our brains are mashed potatoes. So 6x is going to... What's 220 minus 36? 184? Okay. So divide by 6, divide by 6. And you're definitely going to get a decimal, but that's okay. So 184 divided by 6 equals 30 point what? 67? I knew 67 was going to come up at some point. Now, I will say this. Your classwork is going to be 5 through 8 on the worksheet. And there's 2 mistakes that kids have been making all day long. So if I may share my ideas with you. Well, you know what? I'm gonna pause this video for now. And then when we get to the mistake area, I'll turn the video back on. So if you could start now with number 5, then do number 6, please. If you would start that now. I'm going to pause this. Okay, so like for number 5, remember it's the outside times the sum equals the outside times the sum. So I always start with the secant with the x in it. What's the outside? What is the outside? Okay. Times the sum. When I talk about the sum, I mean you add the outside plus the inside. So what would that look like? Plus. Beautiful. And you set that equal to the outside, which is 8. Open parentheses for times. The sum, which would be, what is it? Plus 13. Perfectly appropriate. 100% absolutely correct. But I'm going to point out 2 mistakes kids made today, and then I'll leave you on your own. When you have 7 plus x, don't be putting no 49x. Those are not like terms. You cannot add those. The only thing you could do is use the distributive property of multiplication. So like 7 times 7, which is what? And then 7 times x, which is... And in this case, you could distribute, but I wouldn't. I would just use a calculator. Because when you see a number, the question is, how do you know when you got to multiply? And the question is this. First, you try to do what's inside the parentheses. And inside the parentheses, I could add 8 plus 13, which is what? 21. And when there's nothing between the 8 and the parenthesis, that means times. When you have an 8, like a number and a parenthesis, but nothing in between, it means times. So you grab your calculator, you drop this down one more time, and then 8 times 21 is 168. I don't know, did that answer your question about multiplying?
No,
So then, if we could just minus 49 from both sides? So 7x equals, I don't even know what that... What's 168 minus 49? I'm sorry?
119.
And divide by 7?
17.
Gorgeous. Okay, I have just one more comment to say, but I need you to have a chance to work out number 4. All right, number 6, a lot of you are getting it, but I just want to make sure I could release you completely. In number 6, it's a little bit, it's the concept is perfectly the same. It's always the outside times the sum equaling the outside times the sum. So I always start with this because it has the x in it. But what's the outside? Okay, it's 9. Multiply it, so you put open parentheses, times the sum. Well, the sum of the outside and the inside. What is the outside? 9. Add it to the inside length. But look carefully. What is the inside length? What is that length? Someone said it. It's 2x minus 7. So I take the outside, and I multiply it by the sum of the outside with the inside, and it looked like that. That's the sum of the outside. That's the inside. I put a plus in between. And I set it equal to the outside of the other secant. What's the outside length of this secant? It's 10. And I'm going to multiply that by the sum of the outside with the inside. So the sum of the outside and the inside means add the outside length, which again is 10 right here, plus the inside length, which is right here. That's plus 8. And you solve that like a regular old stupid equation. Question. How many of you got that right? Raise your hand. How many of you see your mistake? Any questions with that? Like, how did they get that? If you have a question, now's your time. Okay, well, no questions. Let me tell you, just to help you out. You always try to simplify the inside of the parentheses first. Now that's got an x, the 2x. You cannot add that with a 9 or a minus 7. So I would drop down the 9, and I would just drop down the 2x. But you see, 9 take away 7. What's 9 minus 7? But do I put plus 2 or minus 2? Well, 9 take away 7. Do you think that's going to be a positive 2 or a negative 2? So you have to put plus 2. Thank you. And then in this case, unless you want to use a calculator, 10 plus 8 is 18. 10 times 18 is 180. Use your calculator. Since you cannot add the x term and the constant term, just distribute. 9 times the 2x, 9 times the 2. So what's 9 times 2? Thank you. And then 9 times the 2 again is still plus 18. And that equals 180. I don't mind helping you with equations. So minus the 18 here, minus the 18 here, draw your line, cancels. 18x is going to equal, what's 180 minus 18? I don't. Bless you. Divide by 18. Divide by 18. X equals, you said 9? Oh. Is it done? Please don't say it's done. Because they're asking you to find Mn. The distance from M to N. That becomes an input value. Now listen. You go over here, and the distance from M to N, write it down. The distance from M to N, think about this, little rams. From M to N is 2x minus 7. You take that 9, plug it in here. Notice from M to N is 2x minus 7. So I'm going to say 2 times x, which we know is 9, minus 7. It was an input value. What was that, 18 minus 7? So what's the final answer? 11. Now you, kids, you only have 2 more to do. And I know you could do this. Look at the examples. You could go home, watch the tape again. It's only 30 minutes. And I just wish you the best. I know you're going to do it. All right, thank you.